This is section 313, and we're going to take a look at using all of the different things that we've talked about inverses, and we're going to put them together. So we're going to re-examine using the inverse definition, finding the inverse, and then graphically determine if things are inverses of each other. So the first is using the definition of an inverse. And so you can prove if two functions are inverses of each other by using this definition, right? And what this is saying is you're plugging whatever it is into the other function. So I could take my g of x, which is this one right here, and I could plug it in to x into my function. And so that's what this is here. Now from there, you want to simplify it and get x. So I can distribute the 3/5. That's going to cancel out, and I'm left with x. The 3/5 times 25. The 25 and the 5 will cancel out, and so I'm left with 5. And so you get 15 minus 15, which is just going to be x. The next is you can show if they're inverses of each other by just finding the inverse. So on this top equation for my f of x, if I use the method for us to figure out the inverse, switch the x and y, and now get y by itself, so add 15 to both sides. And then here, we're going to have to multiply by 5, divide by 3 to cancel that out. So we're going to multiply by 5/3. And so if I distribute that 5/3, you're going to end up getting 25 here because that's going to cancel out and you get 5. 5 times 5 is 25. And that happens to be what my g of x is. And so I know that they are inverses of each other. And the last is going to be graphically. If you were to plot both of them, the big thing is, remember, it's going to be symmetrical over y equals x. You should fold it over. That dotted line that you see, which is y equals x, if you fold it over, there should be symmetry there. Now let's look at this one. And I want us to kind of pay attention just a little bit to the methodology here, because these are rational inverses. They're a little different because we haven't really had to deal too much with rationals. But same idea. Are they a composition of each other, and can I simplify it down to x? So this is saying take your g function and plug it in for x. Now if I do that, I get this statement here. 2 over x minus 10, and then plus 10 off to the side. Now we haven't really seen complex fractions like this before. Now what this actually means is, remember, fraction means division. So this is saying 2 over 1 divided by 2 over x minus 10. So we're just making a division statement. So we're dividing here. Now that division statement means that 2 over x minus 10, that's going to have to flip. Because whenever we divide with a fraction, you switch those, you turn it into multiplication. Now the 2's cancel out, and so you're actually left with x minus 10. And so then we have the x minus 10 plus 10, the 10 and the negative 10 cancel out, and you're left with x. So just know that you're going to have to do that little division flip thing. You're going to have to rewrite it to help us visualize what's going on there. Now the next one is also finding the inverse. And this is another thing we're not used to. I could switch the x and y, and I can at least get that 2 over y by itself. And this is where it gets weird, because we look at that and we're like, wait, y is in the denominator. Well, how do we get it out of the denominator? You have to multiply by it. And so if I multiply both sides by y, we're going to get that statement there, because then the y's cancel out here. And now from there, we have this y times x minus 10. We're going to divide both sides by that x minus 10, because this is multiplying, right? Y times x minus 10. You're going to have to divide both sides by it. To get it to cancel out. And so that's where we're going to get y equals 2 over x minus 10. And so they're the same. So I know that they're inverses of each other. And again, the last is you look at a graphing utility and see, are they symmetric over y equals x? In this case, they are, so therefore I can conclude that they are inverses of each other. So these are the three ways for us to determine an inverse. So what did we learn today? We learned basically how to determine if it's an inverse. It's just information that we already knew, and we kind of put it together. So we examined, you can create a composition of each other and they simplify to x. You can take a look at it in terms of it being symmetric over the line y equals x for a graph, and then you can also just switch the x and y, find the inverse, and then compare. So what line are inverses symmetric over? That is the line y equals x. And then what do we swap to help us graph an inverse? It's going to be y equal, you have to switch the domain and the range, the x and the y. And that's why the first step when we find the inverses is we switch the x and y.